Hey folks, so this is section 5.2 from your notes, and I'm going to go through in this video a new parent graph as well as some exponential rules that you would have learned back in Math 102. So these are just going to be a review. But let's first talk about a new parent that we have. This parent is called the exponential parent, and the equation of this parent is going to be a raised to the x power. The a has some restrictions on it. First of all, it has to be greater than 0, or we would say it has to be positive, and it also cannot equal the number 1. If it equals the number 1, 1 to any power is just 1, so that one would be really boring. So let's talk about the parent graph. And the parent graph on this guy is, we could plug in a lot of numbers for this, but for now we will just do the normal parent, and I'll walk through how I got these numbers with you in class. First of all, the special point that we're always going to have is the coordinate 0, 1. This will also be my y-intercept, so I can go ahead and fill in that part of that, 0, 1. And the reason for this is anything to the 0 power is always 1. So if I plug in a 0 for my power, anything to the 0 power is equal to 1. And then what we're going to have is a horizontal asymptote that runs along the x-axis. And so as with all horizontal asymptotes, this is something I'm getting closer and closer and closer to. So on the left side of the graph, I'm getting closer and closer and closer and closer and closer to that fence, that horizontal asymptote. On the right side of my curve, it actually almost looks parabolic, where it goes up very quickly and does not approach anything. It does not approach a horizontal asymptote. It does not approach a vertical asymptote. So this is the overall picture of our parent graph. The domain on this guy is going to be negative infinity to positive infinity. The range has nothing down on the negative side, so the range is going to begin at 0, but that is a horizontal asymptote. It doesn't touch it, so we're not including the 0. The y-intercept I've already discussed, and the horizontal asymptote I've also already discussed, occurring at y equals 0. That a in our equation is going to be the base, and this is the number that we're going to actually know. So what you're going to be seeing as you graph these are things like y equals 10 to the x power, or y equals 2 to the x power. You're always going to know what that a value is. But the x is going to be the exponent or the power, and you won't know that. That's going to be our normal variable that we've always had. Now, some properties of exponents, these are things that you would have learned back in Math 102, so these are going to just simply be some reviews here. Number 1, if I multiply two like bases, what do I do with the powers? Well, first of all, I need to keep my base, and I'm going to add my powers. Keep the base, add the powers. Rule number 2, when I'm dividing like bases, again, keep your base, but this time you're going to subtract your powers. Rule number 3, when you raise a power to a power, once again, keep your base, but this time you're going to multiply your powers. When you raise a power to a power, keep your base, multiply your powers. Number 4, when you have a product, two things multiplied together, and that product is being raised to a power, then every single piece of the product or factor can also be raised to that power. Please do not call this distribution. Distribution only works with adding and subtracting, and this is not adding and subtracting. Number 5 is a very similar rule, only this time they're not factors. They are two things being divided that are raised to a power. Each of those pieces can be raised to my power. Number 6, I just mentioned a moment ago, anything raised to the 0 power is always 1. Rule number 7, we ran into this back when we were dealing with imaginary numbers. Anytime you have a negative power will make you move. If you're in the numerator, your negative power causes you to go down to the denominator. And if your negative power is down in the denominator, it makes you go to the numerator. And then number 8, this one's a bit different. If you have the rth root of a to the tth power, then this can be turned into an exponent. I can get rid of my roots. This is the same thing as base A raised to the t over r power. The way that I remember this is that this is a root. When I think of roots on a tree, the roots on a tree are down at the bottom. However, the tree itself is up on the top. The tree itself is up on the top.